Hello friends, welcome to Mechanical Engineering online classes. Today's lecture will be delivered by Miss Shravani Sriramoju.
Before solving any problem in the queuing model, we have to know certain operating characteristics and notations involved in the queuing system. The first one being the queue length. Queue length is denoted as LQ, length of the queue. This indicates the average number of customers waiting for service. So if the lambda is arrival rate and mu is the service rate, then length of the queue can be calculated as lambda square by mu into mu minus lambda, where mu is the mean service rate and lambda is the mean arrival rate. Second one is the length of the system, or simply system length. This is denoted as LS, system length. So this indicates the average number of customers in the system. That includes all the waiting customers as well as those who are already taking service. So those being served. So those being served plus the waiting customers is the system length. So this LS can be found as lambda by mu minus lambda. This gives us the average number of units in the system. This is LS. The third operating characteristic is the waiting time. Waiting time means waiting time in the queue, denoted as WQ, waiting time in the queue. This denotes the average time of wait in the queue. Means average time a unit is spending which is waiting for the service to be done on it in the queue is this WQ. WQ can be found as lambda by mu into mu minus lambda. Fourth important characteristic is the total time spent in the system, denoted as WS. So this indicates the average total time spent in the system, that is from the arrival to departure. From arrival to departure, whatever total time is spent, average time, that is the WS. WS can be found as 1 by mu minus lambda. Fifth one is the utilization factor, also called as traffic intensity. Utilization factor of traffic intensity is denoted as rho. So the traffic intensity or utilization factor is that proportion of time a server actually spends with the customer. So how much is a server spending with customers is the utilization factor or the traffic intensity rho, which is given as lambda by mu. So lambda by mu is a utilization factor for the system. So if we are considering an m by 1 system, so that means it is assumed that the number of customers arriving in time interval say t will follow a Poisson process with parameter lambda. Equivalently, the interval between any two successive arrivals is exponentially distributed with that parameter lambda, right? The time taken to complete a single service is exponentially distributed with a parameter mu, and the number of servers is 1. That is what the meaning of this m/m/1 is, right? So although not explicitly mentioned that both the population and queue size can be infinity, the order of service may be assumed to be first in first out. Nothing is mentioned. Suppose it's just this is mentioned, so I am assuming it is a first in first out. So the steady state probabilities, if at all we have to write the probability as Pn, steady state probabilities of the queuing system can exist only when the traffic intensity is less than 1, means when lambda by mu is less than 1. The probabilities may be written as say Pn is equal to P of number of customers that are in the system. How many number of customers are there? N. We are writing Pn, right? So number of customers in system is N. So we can write this as lambda by mu whole power n multiplied by 1 minus lambda by mu, where n is from 1, 2 and so on until n. So in case we are assuming that the probability there is no single unit or so no single customer in the system, then it is P0, probability of 0 units in the system. If the probability is that there is no customer in the system to be served, that means what will happen, this n becomes 0 and then our P0 will be simply 1 minus lambda by mu. So this is the probability that there is no single unit in the system. Probability of 0 customers in the system. That means that the service unit is idle, the server is idle. So this is the case of idle server. The probability is 1 minus lambda by mu. Now in case suppose k is the number that of units that is possible. So if probability of n which is greater than k, the probability of more than k units in the system. So where n is the number of units in the system, then the probability will be lambda by mu whole to the power of k plus 1. So this is how we find the probability when the probability of more than k units in the system is happening. K units means k customers, where n is the number of units in the system. Its probability is given as this. So this is the general formula for the probability. So this probability distribution is also called as geometric probability distribution. So this we are following geometric probability distribution. So from that only we are deriving 0 customers or more than k customers probabilities. So these formulas are important to solve a problem. For this model 1, first model is this m by 1. Let us solve a problem. The question is, at a particular petrol filling station, customers arrive according to Poisson process with an average time of 5 minutes between arrivals. Service time is exponentially distributed with mean time of 2 minutes. A. What is the average queue length? B. What is the average number of customers in the system? How many customers are there on average in the system? So this is the question. So since it is given that the arrival is according to Poisson process, then the inter-arrival time will be the parameter lambda. So 1 by lambda is given as 5 minutes. 5 minutes means it is 1/12 of an hour, or lambda is nothing but 12 per hour. Arrival rate is this. So similarly, the service is exponential. So that is given as 1 by mu. It is given in minutes, right? So it is 1 by mu is 2 minutes, or 1 by 30 hours. So mu can be written as 30 per hour. So service is 30 per hour. So if we carefully watch, the arrival is 12 per hour and the service is happening 30 per hour. So lambda is less than mu. So lambda is less than mu means this is a steady state. So a steady state solution exists, because we have already discussed that we will solve only steady state problems. So lambda means the traffic intensity, our what do we call that? The utilization factor is less than 1, which is lambda by mu. So that comes under steady state. So we shall now find the first one. What is the average length of queue? Length of queue is denoted as LQ, and LQ is given by the formula lambda square by mu into mu minus lambda. We know the value of lambda, we know the value of mu. If you substitute it here, we have 12 square by 30 into 30 minus 12. This comes out to be, so I got it as some 0.266, or even if you're not using a calci, you get it around say 4 by 15, which is this 0.266. So that is the length of queue. Then let us find the average number of customers in the system. It is LS. LS can be given by lambda by mu minus lambda. This is nothing but again our 12 by 18. 12 by 18 means 2 by 3. So this is the length of the average number of customers in the system, LS. So the question where we use the probabilities goes on this way. The arrival rate of customers at a booking counter follows Poisson distribution with a mean of 45 per hour, and the service rate of the counter clock follows Poisson distribution only. So service and arrival both are following Poisson distribution, and the service is happening with a mean of 60 per hour. What is the probability of having 0 customer in the system? Means P0. Second question is, what is the probability of having 5 customers in the system? And C is, what is the probability of having say 10 customers in the system? 0 customers means P0, 5 means it will be P5, 10 means it will be P10. And finally find LS, LQ, WS and WQ. So this is the question. So here the given data is not just time, it is the rate is given. Rate means per time. So in the previous problem directly time is given, and to find the time we have to reciprocate it. Per time is what the rate is, right? So here straight away the rates are given. So lambda is 45 per hour, which is given here, and mu is 60 per hour, that is given here. And let us find the traffic intensity rho. Rho is nothing but lambda by mu, which is 45 by 60, which is nothing but 3 by 4, 0.75. So this is less than 1. So this is a steady state situation. So let us find the A bit probability that 0 customer is existing in the system. Probability can be found as from the formula. So this is the geometric probability distribution formula that we use, right? So probability that 0 customer is in the system is nothing but P0, which is 1 minus lambda by mu. Lambda by mu is nothing but rho, our traffic intensity. So we can find P0 from here. So P0 is equal to 1 minus rho. 1 minus rho means rho is 0.75. So 1 minus 0.75 is nothing but 0.25. This is the first answer. Then B. B is, what is the probability of having 5 customers in the system? Means P5. So if we go back to the formula of the geometric probability distribution, Pn, here n is 5 in the given question. Then if n is 5, what will be our P5 from this? P5 will be lambda by mu, or otherwise lambda by mu is simply rho. Rho power 5 into 1 minus rho. So P5, or okay, I'll write the whole formula here. Since Pn is equal to what is it? Pn is lambda by mu whole power n into 1 minus lambda by mu, where n changes from 1 to, okay, even for 0 we get the answer from here only. So PO will be 1 minus lambda by mu. Since lambda by mu is rho, we can find P5 as let me write Pn in terms of rho. It is rho power n multiplied by 1 minus rho. So P5 will be rho power 5 into 1 minus rho. So rho is nothing but 0.75. 0.75 power 5 into 1 minus 0.75 is 0.25. So what is the value of P5? So I got this as 0.05932, whatever it is. I'm just writing up to 4 decimals only. So that is the probability of the system having 5 customers. And the next question is, what is the probability of having 10 customers in the system? Means P is 10, N is 10, sorry. So this formula will become rho power 10 into 1 minus rho. It is 0.75 power 10 into 1 minus rho is 0.25. So this is 0.014078. So I'm writing it as 0.0141. I got 4078, but I'm rounding it off to 41. So this is the probability for the system having 10 customers. Then we have to also find LS, LQ, WS and WQ. We know the formulae. What is LS? LS is the system length. So that can be given as lambda by mu minus lambda. Lambda is 45 per hour and mu is 60 per hour. 45 by 60 minus 45. 45 by 15. This will be 3. We should also find LQ. LQ is a queue length, average number of customers that are who are waiting for the service to be done. The formula is lambda square by mu into mu minus lambda. This is 45 square by 60 into 60 minus 15 is 15. Now this will be 45 into 45 by 60 into 15. 60 can be written as 4 into 15 into 15. This is 3. This is also 3. This is 9 by 4. Let us find WS and WQ. WS is given as 1 by mu minus lambda, which is total time in the system. This is 1 by 60 minus 45 is 1 by 15. And WQ is lambda by mu into mu minus lambda. This is 45 by 60 into 15, which is 1 by 20. So LS is 3, means the average number of customers in the system, including those who are waiting as well as being served, has come out to be 3. So 3 customers. This is 3 customers. WS is the waiting time, the total time in the system. The total time means from arrival to departure. How much is this? It is 1 by 15, which is nothing but 0.067. Everything is in terms of hours, right? All the given data. So this is hours. And WQ is also 1 by 20. 1 by 20 is nothing but 0.05 hours. And LQ is 9 by 4. 9 by 4 means 2.25 customers. 2.25 customers means we don't see, because this is math, we cannot force it to be an integer, but actually it will be an integer. So more than 2 customers are waiting for the service. More than 2 means we can consider it to be 3. So we have, whenever we are writing the answer, we have to see that we are mentioning the units. You don't change the values. You don't have to write it as approximately 3. No, whatever is there you will write that only, but you have to mention the units. LS and LQ are number of customers. WS and WQ are the hours, because the given data is in terms of hours.
Thanks for watching. If this video was of help to you, please like it, and share it with your friends. And don't forget to subscribe to our channel.